Howdy! Welcome to Aspire Bound Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice in using StatCrunch to conduct hypothesis testing on a population mean. Let's get started. So this particular problem we're going to look at is about a study that was looking at the years that students actually spend in school to graduate. So 20 randomly selected students were tracked, and the study found that their mean time to graduate from college was 6.5 years. If that's the mean, come on, it's like some people are less than 6.5, some people are more than 6.5. Well, in the end, it doesn't really matter how long it takes you to graduate, because I know from experience, when you get in the real world, they don't care about the date on your diploma. All they care about is, I have a problem. Can you help me solve it? You help them solve their problem, you're good to go. So, however long it takes you to graduate, it does not matter. But it does matter to the schools, because the more students that they can get through the system, so to speak, the more money they can make. So, they have a vested interest in getting students through the process of graduation as quickly as possible. Anywho, 20 randomly selected students, mean time to graduate 6.5 years, sample standard deviation a little more than 3.5 years. Notice we've got the same 5 standard questions that we saw with proportion hypothesis testing. Those stanzas are going to follow us all throughout the hypothesis testing stuff here. So we're going to answer those 5 stock questions, and then we're going to do it with this problem. The claim is that the mean time to graduate is 4 years. So to start off with, we're going to look for our hypotheses, and to start doing that, we think about the claim that's being made. Well, the claim here is that the mean time to graduate is exactly 4 years, so mu equals 4. Next, we write our null hypothesis. By definition, that's a statement of equality. So mu is going to equal 4, but that's the actual claim that was being made. Well, our claim actually has equality in it, and so equality by definition goes into the null hypothesis. So we can't actually adopt the claim like we typically do for our alternative hypothesis. Instead, what we have to do is take the complement of the claim. The complement of being equal to is being not equal to, so mu does not equal 4 is our alternative hypothesis. And notice that inequality there on the alternative hypothesis means that we're going to have a two-tailed test. What's our test statistic? Well, we can go into StatCrunch, go to T-stats, because we don't know what the population standard deviation is. One sample, because we have just the one sample. With summary, because we don't have any data, just summary stats. The options window is going to come up. We'll put our summary stats up there at the top. Make sure those fields for hypothesis test are matching what we have for a null and alternative hypothesis. Press compute, and out comes this wonderful results window, little table there, and the next to last value in that table is always going to be your test statistic. The p-value also there in that results table, it's always going to be the last value that's listed. So next door neighbor with the test statistic. And now that we've got these numbers, we've got what we need to go ahead and resolve our hypothesis test. So to do that, most people just look at the p-value. So here's your critical region, the region of rejection. You've got a two-tailed test, so half of the region is on the left, half of it's on the right. Take that p-value that we got earlier from our results window, we compare it with our level of significance, 5%. We see that, yes, we're inside the region of rejection. We can fit that area for the p-value inside the area for alpha, and therefore we're inside the region of rejection, and we reject the null hypothesis. Alternatively, if we wanted to take that test statistic and use it, we can take the test statistic, 3.18. That's going to put us right about here somewhere, and you can see we're well inside that region of rejection there on the left. And so again, we reach the same conclusion. We're inside the region of rejection, therefore we reject H0. What do you conclude from the hypothesis test? Well, here at this point, we look and see, okay, what do we have with our hypothesis test? We rejected the null hypothesis, so there is sufficient evidence. So it's going to be C or D. And then we have a two-tailed test, so that means we warrant rejection of the claim. That means we're going to select answer option D. Again, if you don't know where these parts are coming from, you got to memorize that pattern. So get that pattern down because it really helps to answer these types of questions. And once you get there, that's all you got to it. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.